So super quick little demo about the Caesar cipher. Caesar cipher is a really commonly used cipher in lots of challenges. It's pretty simple. It's basically a substitution cipher where you are encoding the plain text message. That's what they call it, plain text, into the ciphertext. So the ciphertext is it should be unreadable, and Caesar cipher is a really easy to crack cipher. It's not professionally used, but it's a fun beginner cipher to play around with. Okay, so the C's, I have this wheel here. I like using a wheel to demonstrate it. And Rot 13 is a version of the Caesar cipher that you're commonly going to see. Rot 13 basically says rotate every letter 13 spots from where it started off. So an easier example, Rot 1, it's rotate 1, but people always just say rot. Rot 1 means rotate everything one spot. So if the letter A was in your original, like if we said act, the letter A was in the plain text message, that would be replaced with the letter B. And everywhere in your message, your original message where you had the letter A, you'd swap it out and put the letter B in its place. So we're encoding, this is our plain text, we're encoding this. So everywhere we see the letter C, since we're doing Rot 1, C is going to become the letter after C, which is D. And then T is going to become, let's see, A, B, C, T, U. Oh, it's going to be U. So this BDU would be the encoded version of that plain text message. Okay, pretty simple to crack it. Sometimes you don't know what the rot is, how many places it's been rotated, but there's only 26 different ways that it could have been encoded. So it's pretty easy to brute force a Caesar cipher. It's trivial. Rot 13 is kind of nice because an A is mapped to the N and an N is mapped to the A. 13 is there's 26 letters in the alphabet. So basically everyone is mapped to the one that's across from it in this wheel. And let's see, F is mapped to S and so on. You can choose the key you want to use. Key is how far you've been rotated. So in a Rot 13, the key is 13. In Rot 1, the key is 1. Oh, by the way, how would I unencode this? Well, if you'd have to know how many places it was rotated, or you could just brute force it and try all 26 of them. Well, I guess not 26 because no one's going to do Rot 0 or Rot 26. So because then you get the same exact message. But what you could do is say, oh, it was encoded with Rot 1, so decode it with Rot -1. So take each one of these and subtract 1, shift it 1 to the left. So it's fairly trivial. Oh, what comes before B? 1 character, oh, it's A. What comes before, 1 before the D? It's C. Oh, what comes 1 before the U? It's T. So fairly trivial. So if I were encoding the word hello, notice we have uppercase and lowercase. Usually if there's uppercase in the original message, then you have uppercase in those corresponding locations in the ciphertext. Ciphertext is the scrambled or encoded message. So H, if we're doing Rot 19, so we can use that easily because it's on our thing here. Plain text is on the outside. That's how you read this. Plain text on the outside, ciphertext is on the inside. So H goes to A. Okay. So this would be A. Letter E goes to X. So I would do lowercase x. Well, lowercase and uppercase X looks the same because I'm replacing the E. L is the letter E. Got another one. And then O, it looks like is H. So this would be the encoded version using a Caesar cipher that has been rotated 19 spots. This would be hello encoded. And then decoding it, you reverse that process. All right. Happy coding.